Good morning, one and all. Today we discuss about thermal properties of solids. Lecture number 2 for B.Sc TY students. Paper number 13A, Solid State Physics. You are welcome in Sanjeevanee Mahavidyalaya Chapoli in the Department of Physics. Our college is affiliated to Swami Ramanand Tirutha Marathwada University, Nanded. Now let's start our actual topic, that is thermal properties of solids. In this lecture, we are interested to study about specific heat of solids. Before that, one should know the difference between temperature and heat. What is temperature, what is heat? If it is asked, then there is no need to confuse. So concept must be clear. So let's think about temperature. Temperature is the measurement of average kinetic energy of the particles in the matter. Their average kinetic energy measurement is nothing but temperature. Now heat is nothing but form of energy. Heat is the energy that flows from a warmer object to a cooler object. Warmer object to cooler object. Whatever may be the energy that flows is said to be heat. In short, we can say heat flows from warmer to cooler, warmer object to cooler object. For example, body of a patient and body of a doctor. Whenever doctor touch to the body of the patient, then surely there will be the transfer of heat from body of the patient to the body of the doctor. What is the reason? Because patient's body has more heat compared to, patient's body is warmer compared to the body of the doctor. So doctor's body is cooler compared to the patient's body. So there will be the transfer of heat flows from patient to doctor. Warmer to cooler. Got it? Here you see, have you ever noticed that on hot summer day the pool is cooler than the hot cement? Pool is cooler than the hot cement. Or maybe that the ocean is cooler than the hot sand. Ocean is cooler than hot sand. The reason behind is saying that heat flows from warmer to cooler. Now let's turn some observations. We take observation. Here 1 kilogram of gold is taken. Here 1 kilogram of aluminum is taken. Mass of the material is same 1 kilogram, but only that different materials are used. And they are heated. And it is observed that heat up at different rates. Here heat is up in gold and heat is up at different rate in aluminum. Gold heats up about 7 times faster than aluminum. See here. Here entire column is shown by red mark. Here only part of a column is shown by red mark. What it shows? It shows that when your 1 kilogram gold and 1 kilogram of aluminum are provided heat with the same type of candle or same type of source, heat source. Then it is observed that gold heats up about 7 times faster than aluminum. These are the observations. Now, second observation is what? Different materials store different amounts of heat energy. Water takes about 30 times longer to heat than gold. Meaning it stores about 30 times more calories. See, here 1 kilogram of water is taken, 1 kilogram of gold is taken. Heat is provided by both of them by same source. Then it is observed that water takes 30 times longer to heat than gold. What it means? It means that water stores about 30 times more calories in it. Then let's turn to specific heat capacity. Different matter, in this slide we have seen different matter, different materials store different amounts of heat energy. With this, we can study the specific heat capacity. Specific heat capacity is nothing but the amount of heat required to raise the temperature of 1 gram of a substance 1 degree Celsius. 1 calorie is equals to 4.184 joule. 1000 joule is equal to 1 kilojoule. 4184 joule is equal to 1 kilocalorie. That is 1 calorie. So, specific heat capacity is nothing but what? The amount of heat required to raise the temperature of the substance, 1 gram of substance to 1 degree Celsius. In this way, specific heat required in degree Celsius, joule per degree Celsius. Water has a specific heat capacity 4.184, ethanol 2.44, aluminum 0.897, granite 0.803, iron 0.449. Means specific heat capacity of water is more as compared to what? These remaining matters. Now, equation we say Q is equal to C into M into delta T, where delta T is nothing but final temperature minus initial temperature, that is change in temperature, where Q is the heat absorbed or released by the substance. See the specific heat capacity of the substance. M mass of the sample in grams, and delta T is nothing but change in temperature. So heat absorbed or heat released we can obtain by using this relation C into M into delta T. Now calculating the energy content of a substance. Calorimetry is the process of determining how much energy is present in a substance. By using this calorimeter, we can determine, we can study that how much energy is present in a substance. Energy stored in a substance using calorimeter. Now, what is the heat capacity? Heat capacity is what, and specific heat capacity is what? These two concepts we discuss in detail. Let's turn first of all towards heat capacity. What is heat capacity? The amount of heat released or amount of heat energy released or needed to raise the system's temperature by 1 degree. It is usually expressed in Celsius or Kelvin. It is expressed in units of thermal energy per degree temperature. So heat capacity means what? The amount of heat needed or required to raise the temperature of a system or of a body by 1 degree Celsius. This can be obtained by using this relation. C is equal to Q by delta theta. Unit of heat capacity is joule per Kelvin. Where C is heat capacity. Heat capacity can be obtained by relation Q by delta theta. Q is nothing but amount of heat energy. Delta theta is change in temperature Kelvin. So C is equal to Q by delta theta. Heat capacity of a substance can be obtained by using this relation. That is amount of heat energy upon change in temperature in Kelvin. Now let us turn toward the important concept on which we are going to concentrate more. Specific heat capacity. In case of heat capacity, we have seen heat released to raise the temperature through 1 degree Celsius. Now here the amount of heat needed or required to increase the temperature of 1 kilogram of a substance by 1 degree Celsius is the specific heat capacity. You are getting it or not? The amount of heat required or need to increase or to raise the temperature of 1 kilogram of a substance by 1 degree, and this is nothing but the specific heat capacity. It is expressed in joules per kilogram per degree, and this can be obtained by using the relation C is equal to Q upon M into delta theta. Unit of specific heat capacity is joule per kilogram per Kelvin. Already I have told you. So again question arises, what is Q? Q is nothing but the amount of heat energy in terms of joule. Delta theta is what? Change in temperature in Kelvin. So in this way, specific heat capacity of a substance can be obtained by using this relation Q upon M into delta theta. So this is the way to study specific heat capacity and heat capacity. So in case of heat capacity, we have taken temperature by 1 degree, and here temperature of 1 kilogram of substance by 1 degree Celsius. This point. So in this way, easily you can define heat capacity of a substance and the specific heat capacity of a substance. And with this slide, we came to know that different materials stores different amount of heat energy. Specific capacity of substance varies from substance to substance. When different substances has different specific heat capacities. So in this way, we have discussed about the temperature and heat, specific heat capacity of the substance, heat capacity of the substance, their difference in detail. So remaining matter we discuss in next lecture. Thank you.